Welcome to part 4 of how to build a solar plant watering system with Arduino. In this part, we will concentrate on how to reduce power consumption of our system. We will measure the power consumption of our setup with the multimeter and check which parts consume the most power between the intervals. Then we will optimize our system. So let's go. So before we start with the actual part of this video, I have to tell you how to correct a little bit of our code because in the last video I did a mistake. I told you that we can outsource the code in header files, but this is not how you use this in C++ code. Normally, you only use header files for the declaration of the function, but the actual implementation of all functions is then in a further C++ file. So now you can find one header file with just the declaration of all the functions, and the actual implementation is in a .c++ file with the same name, and it implements or it includes the header file, and then we have to write the code inside the C++ file. How to do that? You can Google this online, of course, or you can just have a look at my GitHub and look in the code of part 4 how you can do this. To measure the power consumption of our system, we will need a multimeter for this. And in the picture, you can see that we put the mass to COM, so the black cable, and the red cable to milliampere. We have then to turn the multimeter on and set the switch to 200 milliamperes. And if you do not have a multimeter, this is no problem. You can just watch and optimize the system anyways. In the picture here, you can see where we need to measure. You can leave everything as is, but the cable from the power in pin of the Arduino and the 5-volt output of the solar power manager must be plugged out, so we can put our multimeter in between. If we measure now between the two cables, the circuit will be closed by the multimeter and it can measure the power consumption while our system is running. The battery we use is far below the advertised capacity of 1200 milliampere hours, and it has in reality only 260 milliampere hours capacity. To calculate how long it can last, we can divide the capacity by our load current, which I've done here in this calculator, but you can do this in a normal calculator. And then we can see that it only lasts for 10 hours, which matches my experience that the battery is empty overnight and the system can start again when the sun is shining. So in the next steps, we will check which components consume the most current and optimize our system. After measuring, we know that our capacitive soil moisture sensor is the bad boy in this setup, which makes sense as it constantly measures the soil moisture even if we are in between intervals. So let us use a little trick to solve that problem. We will connect the ground pin of our sensor to a digital pin of the Arduino. Then we can configure the digital pin as pin mode output. And if we set the value of the digital pin after that to low, then it will be connected to ground and our soil moisture sensor has power and we can measure the value. So the circuit is then closed. And if we want to stop measuring, we just set the pin mode to input. And this way, the sensor circuit is not closed and it will not consume power in between the intervals. In this picture, you can see how it works. So we set the pin mode to output and then digital write low. And then we will have a closed circuit and we can get the value of the sensor. If we do not want to measure, we set the pin mode to input and then the sensor will consume no current at all, which saves 100% of what the soil moisture sensor normally consumes in between the intervals. One very important thing to do this trick is not to exceed the maximum of 40 milliamps per pin, as you can also read in the documentation of Arduino. We already know that one sensor only uses around 6 milliamps, so we are safe, but if you exceed the value, then the pin will be damaged and will not be, you cannot use this anymore, so be aware of that. Maybe you already noticed that we are short on digital pins on our board, but we still have some analog pins available. And the documentation says that on our Arduino Nano, we can use all analog pins as digital pins except A6 and A7. On the following two pictures, you can see how our setup looks before our optimization and after the optimization with the ground pins of the sensor connected to the digital pins so we can control the sensor. So let's have a look at our code. We switch our sensor signal pins from before to A4 until A7. And of course, we need to change our hardware setup as well, so take care to connect everything like we configure it in our code. Then we will also need 4 digital pins to control our sensor, as I described before. You can use, of course, A0 to A3. In this case, I'm also using the free one, the free digital pin number 6 as well. Doesn't matter, but as long as you connect the hardware correctly. Then in our init or in our setup function, we set all sensors to pin mode input. This means the circuit of the sensors is not closed and we cannot measure. Also, we have to adapt our calc soil humidity function. We have to pass, of course, the sensor signal pin so we can get the value and measure. And then we will, this is new, we will need the digital pin where the ground of our sensor is connected to, so we can turn it on or off. So in this case, we want to measure. So we set this pin to output mode, and then we set it to low. This means the circuit is closed and we can measure the value. And then we will wait around 3 seconds. I don't know if we can wait a little bit less. You can try it out. I just put this 3 seconds and it was okay. And after that, we can measure our value. and we will save this and return it here. And then that the sensor does not consume any power anymore, we will set the pin mode to input again. So then the circuit is not closed anymore. So after returning our values, I write them to the e-paper like before, but now this is different because the functionality is separated. So in our water function, we will pass now the values which we calculated because the sensors have no power anymore. So we just save the value and pass it to our water functionality. And there it's similar like before. We will water or we will start the water pump or not if not necessary. And also while testing everything, I adapted those values because they were not as precise as I thought before. So you have to try this out as well and find your best values for the range where you want to water, but this is on your side. My system runs now over 1 week only solar powered, exactly with the setup I showed you here in this video. So I'm quite confident that unless components will break or there's no sun at all, that the system will run like forever with this setup. The code for the last part is available on my GitHub again. The link is in this, you can find it in the description. And also I am thinking about optimizing the setup and maybe switch the relay with a smaller component. But first I will test the system for a few more weeks and then I will think of a solution for where to put all the cables and the other stuff. Maybe I will build a little box for it or something like that. So maybe I will create another video after long-term experience with the system. If you have any questions or if you have built the same and just want to let me know, just write it in the comments. Yeah, and then thanks for listening and watching the whole series, hopefully. And then see you in the next video.